Well, good to see you all. Welcome all of you again to virtual classes of science here. In this session, we are going to discuss the concepts of projectile motion, which is an example of two-dimensional motion in your kinematics unit. And we will see this one in detail throughout this session. So let us enter into the topics through the virtual classes of science here. So projectile motion. What is meant by projectile motion? How we can define projectile motion? I'll define a projectile motion in a very simple manner or by two simple terms. I would like to say a projectile can be called as something which follows these two conditions, that is u not equal to 0 and a is equal to minus g. So I would like to say mathematically, if there is a question, what is a projectile? Even if you write this, you will get the complete score. So that what does it mean? A projectile is something which has got a non-zero initial velocity, which has got an acceleration. If it is under gravity, it is moving through gravity with acceleration a is equal to minus g. So for projectile, to describe the projectile, let us have a two-dimensional Cartesian coordinate system, say origin O, X and Y. So this point, the initial parameters or the initial inputs that we know about the projectile are O, which is the point of projection, and we have got U, and we can say U can be either along the x-axis. If it is along the x-axis, we will call that one as a horizontal projection. If it is along the y-axis, we will call it as a vertical projection. Whereas here, I am going to describe this motion with u making an angle theta. So that is neither along x-axis nor along y-axis. So we can say that this is an oblique projection. This is an oblique projection. It is not along the x or nor along y. So what are the initial parameters we know? We know the point of projection O, we know the velocity of projection and theta, which is angle of projection. This is moving under gravity. So AY is equal to minus G. So as I said, this is a motion along a plane, or we are studying this one as an example of a two-dimensional motion. For me, this is always convenient. If there is a two-dimensional motion, I always break that one into two independent one-dimensional motion. One along the x-axis and the other along the y-axis. So if you are able to solve the x-axis problem and y-axis problem, the projectile will be very simple or very easy to understand. So for convenience, what I am doing is I am breaking this one into two columns. So in the first column, we will be seeing the different parameters of motion. And the second column is left for the x-axis problem. And the third column is meant for the y-axis problem. So I have got this kind of a table. This is meant for the motion parameters. This is meant for analysis of x-axis, and this is meant for analysis of y-axis. So let us move in this fashion. With any two-dimensional problem, let us have the convenience of breaking that one into one x-axis problem and one y-axis problem. So the complexity will be simplified. So the first parameter, what we know about the motion is the acceleration itself. We know the acceleration. And I have already given you ay is equal to minus g. So the y-axis component of the acceleration is ay is minus g. And in my analysis, I have chosen the convenience that there is no air turbulence or there is no air resistance, we can say. So that means there is no retardation, there is no acceleration along the x-axis. That is one of the consideration or assumption which I have taken. So Ax is equal to 0. So these are my initial parameters. So what we can see is along the x-axis Ax is 0, along the y-axis Ay is minus g. Both are constant quantities. Ax is 0, that is a constant. Ay is minus g, that is also another constant. So these two are constants for us. So in the kinematics, we have an advantage, or we have already studied that if acceleration is found to be constant, then we can make use of the equations of motion, like v is equal to u plus at, s is equal to ut plus half at square, and v square is equal to u square plus 2as. That means velocity time relation, displacement time relation, and displacement velocity relation. So all these we can use to find out other parameters. So what is the next parameter we have to learn? The next parameter is nothing but the velocity of the object. Why I am drawing velocity like this? Because velocity has got two aspects. One is initial velocity, the other one is final velocity. So first one I am leaving that one for initial, and the other one is final. Now look at the diagram. Initial velocity, we know u is making an angle theta with this. I have to find the x component and the y component. What I can do? Drop a normal from the tip of the velocity. This makes a right triangle now. This is a right triangle. So the horizontal component, by resolving the vector u, you will get ux is equal to u cos theta along x-axis. So I have got ux is equal to u cos theta. That is a component of initial velocity along the x-axis. What about the vertical component? That is uy. Uy takes u sin theta value. So I have got the initial velocity along the y-axis as u sin theta. So that gives the initial components of velocity along x and y. Now what is the next step? I have to find the final velocity. How will you find the final velocity? If you know initial velocity, and to find the velocity after a time t, what we can use is, we can use the equation v is equal to u plus at, which is velocity time relation. So here I can write Vx is equal to ux plus axt, and here Vy is equal to uy plus ayt. So after time t, what happens for the velocity of the projectile when it is moving under this condition? Look at here, ax is 0 and ux is u cos theta. So I can write Vx is equal to u cos theta. That means there is no change of velocity along the x-axis. That is obviously clear because there is no acceleration. I have plotted that one as equation 1. So if I plot a graph of x component of velocity against time, my graph will be a straight line parallel to the time axis with the value u cos theta always throughout the motion. So this is my first graph which I have got. That means at any point on the trajectory of the projectile, it has got a constant x component of velocity. Now what about the y component? Y component becomes Vy is equal to uy is u sin theta, ay is minus gt. Let me call it as equation 2. So what is that happening? We can see that final velocity is decreasing as the time is increasing, because final velocity takes the form of u sine theta minus of gt. U sine theta is a constant, t is increasing, and tg is a constant. So if t is increasing and g is a constant, this is a negative parameter. So what will happen? Vy decreases from u sine theta, decreases, and it goes to a zero value, and it can be going to a negative value. So if I plot the velocity time graph according to the equation 2, the shape of the graph Vy versus t, if the initial value is u sine theta, what happens for that? It decreases. It's a linear decrease because this equation, because Vy is equal to u sine theta minus gt, or I can put it as minus gt plus u sine theta even. This is similar to, sorry, I'll put it as minus gt plus u sine theta. This is similar to our y equal to mx plus c relation for a straight line. From this, m is negative, so the slope is negative. Obviously the slope value is nothing but the slope value will be g. So at some times in the trajectory Vy goes to 0, whereas we have already seen Vx is always constant. That means along the trajectory velocity completely never goes to 0, because x component always remains constant as u cos theta, whereas Vy varies, and after some time it may be going to a negative part also. We will see this one in detail while we are analyzing the trajectory. So that are the variations of velocity with respect to time for a projectile. Now what is my next aim? My next aim is to find out the position component or the displacement component. Next aim is to find the position of the object. What I can use for this one is, I can make use of the equation of position time relation, which is nothing but, that is S is equal to ut plus half a t square. So for x axis I can write it as x is equal to u xt plus half a x t square, and for y axis y is equal to u y t plus half a y t square. By simply making use of position time relation, I will get the x component after some time t and y component after some time t. So substituting, ux is u cos theta, ax is 0, so x is nothing but, that is u cos theta into t. Let me call this one as equation 3. Suppose if I want to plot that one as a graph, that is x component variation with respect to t for a projectile. That means x versus t graph. What will be the shape of the graph? X versus t. Look at that. X is equal to u cos theta t. This is also similar to y is equal to mx plus c. So initially, if the particle was at origin, what happens for the x component? It is continuously increasing, we can say. As t increases, u cos theta t increases. C is y-intercept, that is 0. So the shape of the graph will be like this. X versus t is like this. The slope of this graph, if you take the slope of x versus t, will be nothing but Vx, because this gives delta x divided by delta t. Slope is represented by u cos theta. So that shows the variation of x with respect to time. We got that x is continuously increasing with a constant slope as the time is increasing. Now what about y component? Y component is y is equal to uy. What is uy? It is u sin theta times t plus ay t square. Ay is minus g. So this becomes minus of half g t square. Call it as equation 4. Variation of the y component with respect to time. Looking at the equation, we can say that is similar to y equal to ax square plus bx. Ax square plus bx. So I am plotting that one on a graph. Variation of y with respect to t, or y versus t. Y is equal to u sin theta t minus half gt square, or this is minus half gt square plus u sin theta t. This is similar to our equation y is equal to ax square plus bx. This is a standard equation of a parabola, but you can see a is negative. So what will be the shape of the graph? The y versus t graph will be an inverted parabola. Y versus t graph will be an inverted parabola. So we have seen the variations of x, variation of v, variation of y. So if you have got this kind of a table in you, we can say that the study of projectile will become very simple. Now we are going to analyze more parameters from this. First we will see what will be the shape of the trajectory. We know only the initial condition and we have got some final parameters. We should know what way the particle will move in air, or that is called as the pathway or trajectory of parabola. Trajectory of parabola. Or trajectory. In mathematics, what is trajectory means? Trajectory means a relationship between x and y. Trajectory in 2 dimension means a relationship between y and x, or x and y. What we can make use from here is we have equation 3 and equation 4. You can make use of these two and make a relationship between y and x. What's the simplest way? Replace the t over here with x. So I am using equation 3. What is equation 3? From 3 we have x is equal to u cos theta into t, or I can write t is equal to u cos theta over x. Substituting this one in 4, the 4 will become, we have y is equal to u sin theta times t. T is replaced by, this is in the reverse order, x divided by u cos theta. This is x divided by u cos theta. So that is x divided by u cos theta. Minus half gt square, minus half g times t square. What is t square? T square is x square divided by u square cos square theta. U cancels, sin theta by cos theta is tan theta. This is x tan theta minus, this is a constant, g divided by 2 u square cos square theta into x square. Like I said earlier, this is also similar to which equation? Y equal to ax square plus bx. So we can say y versus x, or the trajectory of projectile is a parabola. Trajectory of projectile is a parabola. If I plot that shape of the graph, I will get that one as the shape of the parabola. I mean, the trajectory of projectile will be, this is y, this is x, this is the point of projection, this will be the shape of the graph. We can say this constitutes the two-dimensional space covered by the particle. So we have got a standard formula for the trajectory, which is y is equal to x tan theta minus g by 2u square cos square theta into x square. This is a standard equation of the trajectory of the projectile. Let me call this one as equation 5 for you. Now, parabola, it is very easy to analyze a parabola. Why? For parabola, we can choose important points as, or from this we can say that this is the starting point, which is a point of projection, and this is nothing but, this is the highest point of projection, and this is the final point, or we can say that is the maximum x distance covered. X distance covered, we will call that one as the range of the parabola. The range of the parabola, and this point we can represent it as r. So we can say range is an x parameter, or range is an x-axis quantity. What about h? H is the height covered. This is the highest point of the trajectory. Height is obviously what? Height is obviously a weight component. Look at the parabola. What will be happening when the particle is moving? We know that initially it was having velocity u, and at times x component and y component of velocity, we found that it was changing. It was changing. Let us see what happens for the change. We have already noticed that x variation is, velocity x variation is Vx, it's a constant, u cos theta throughout the motion, and y component is varying as Vy t u sin theta. It is decreasing with a slot of g, as Vy is equal to u sin theta minus gt, and Vx is equal to u cos theta. Now we are going to analyze the parabola in detail. What are the important aspects of parabola? The first thing is nothing but how much time is taken by the projectile to make this parabola. What is the time taken by the projectile to move from O to R, or till what time the projectile was flying? And that is called as what? That is called as the time of flight of the projectile. That is called as the time of flight of the projectile. Now I will take that side for making the analysis simple. The time of flight of the projectile. The time of flight of the projectile. What is the time of flight of the projectile? It's a time taken by the projectile to move from O to R. Okay, we know that a parabola has got a peculiarity. Its first half, this much is called as its first half, this is called as its second half. Okay, So if there is a parabola O, and this is the highest point, or we can say this is a bisector of the parabola, and this half and that half are known as symmetric halves. And as there is no air resistance across it, we know that the time taken for the first half will be same as the time taken for the second half. So if the total time taken is t, or that is called as the time of flight t, the time taken by the projectile to reach from O to H will be half of t. So that is t by 2. So in t by 2, the projectile starts from O and it reaches H. What happens when the particle is moving upward? Upward motion is characterized by our second equation, which is u sine theta minus gt. It's a y-axis problem. If you remember the column which I have drawn, which is Vy is equal to u sine theta minus gt, this is our second equation. So as the time is increasing, this value is decreasing. So when this is moving up, the y component is decreasing. We can say at this point, let Vy has got this much height, this point Vx will have this height, this point Vx will have the same height, but Vy must have decreased, because Vy is decreasing as per this, and Vx is equal to u cos theta always. So at this point, what happens for Vy? Vy becomes 0. That is why the particle is unable to move much higher. The y-axis motion is stopped. That means at this h point, it has got only one component that is still equal to what? X component. This is Vx, this is Vx, and this is also Vx. All has got the same value. So at h, the time taken is t by 2. And what happens for Vy? Vy becomes 0. Make use of the equation 2. Equation 2 is Vy is equal to u sine theta minus gt. Substituting this, I'll get Vy is equal to 0, u sine theta minus g into t is t half, or t by 2. Put it as t half. Okay, half of the time of flight. I am calling it as half of the time of flight. So what is half of the time of flight? Rearranging, I will get half of the time of flight as equal to u sine theta divided by g. So what will be the total time of flight? Total time of flight will be 2 into t half, or that is equal to 2u sine theta divided by g. This is my equation for time of flight. So I will put this one as equation 6 for you. So we have found how to get the time of flight by looking at the motion along the y-axis. So time of flight can be analyzed using an analysis through y-axis. Now next point is how much distance is covered in the x direction, or we call it as the range. The range of the projectile. What is the range? Range is known as the maximum horizontal distance covered, or that is also called as horizontal range. Range is obviously, as I told you, it's an x-axis problem. So this is an x-axis problem. If you remember the table which I have given, the x distance was equal to u cos theta multiplied by t as per equation 3. I can simply say that when the time is completed, the particle reaches r. That means when t becomes capital T, x becomes capital R. So my equation 3 changes into R equal to u cos theta times capital T, or R is equal to u cos theta and T is 2u sin theta divided by G as per this equation. Look at this, what I will get over here is u times u square 2 sin theta cos theta over G. 2 sin theta cos theta, 2 sin A cos A, that is nothing but sin 2 theta. So this equation for range becomes u square sin 2 theta over G. Equation 7 of analysis of the projectile. So what we have done is, to find a horizontal range, we have chosen an x-axis problem, or this is an x-axis problem. We took the equation for x component of the displacement. When t becomes capital T, x becomes the range. That makes the analysis very simple. Now what is the next aspect that we should get? We should get the highest point reached by the projectile. Okay, before that, we will add one more point onto the range. As we have got u square sin 2 theta divided by G, sin for a given value of u, suppose u is constant, that means a particular projectile or a given projectile. So u is constant. In certain problems you can say that for a given projectile, it can be for a given gun or a given missile, or for a given person who is throwing, we can say that u is a constant for that. What can vary? The theta can vary. That means angle of projection can vary. It can vary from 0 to 90 degree, as we have seen. This can vary from 0 to 90 degree. And as well, sine value also will vary. So for maximum sine value to obtain, what is the condition? Sine 2 theta have to be equal to 1, because 1 is the maximum value of sine. If sine 2 theta is 1, this indicates 2 theta is 90 degree, or theta have to be 45 degree. So what we can say, for a given person to reach maximum range, he need to throw the ball at 45 degree. Or for a given gun to reach maximum range, it have to be projected at 45 degree with respect to the horizontal. So that gives the maximum value. So when theta is 45 degrees, sine 2 theta is 1, a range becomes maximum. That maximum range can be written as u square by G. This is the expression for maximum range. So that gives us an idea about which one? Maximum range condition of the projectile. Maximum range condition of the projectile. 45 degree gives us the maximum value of the projectile. So that is this discussion on the horizontal range. Now the next concept is the maximum highest point, or the highest point reached by the projectile. Highest point reached by the projectile. Highest point reached by the projectile. Which is highest point reached? Okay. Before that, I will discuss one more problem. A range itself. We have R is equal to u square sine 2 theta divided by G. Now we can say that for a given theta, we will get a given value of R. This is theta 1 is equal to theta. Suppose another value theta 2 is chosen, which is equal to 90 minus theta. What are these two angles called as? theta and 90 minus theta, they are known as complementary angles. Complementary angles. For complementary angles, we can see for this range will be u square sine 2 theta divided by g, and for theta 2, this is r1, r2 is equal to u square sine 2 into 90 minus theta divided by g, or sine 2 into 90 minus theta is sine 180 minus 2 theta. That also gives the same value as which one? U square sine 2 theta divided by g. So what is the observation? For an angle theta and 90 minus theta, the ranges are equal, or we can say that for complementary angles, the ranges are equal. So what we have got the observation as, for theta equal to 45 degree, the range is maximum, and so this, suppose this is 45 degree range, and suppose I throw a projectile at an angle of theta, that gives a range like this. This is theta, say greater than 90, so 60, that is equal to 60 degree. So 90 minus 60 will be 30 degree. If I, so theta 1 is equal to 60 degree. If theta 2 is chosen as 90 minus 60, that is equal to 30 degree. The projectile will be somewhere like this. Will be projected somewhere like this. This also should give the same range. So for theta 1 and theta 2, we are getting the same range values. So that is another observation for range. Now the next concept is the height reached by the projectile. The height reached by the projectile. Height is obviously a y-axis problem. Height is a y-axis problem. So when the particle reaches the highest point at h, we have already seen Vy becomes 0. And what is the distance covered? This is y equal to h. And what is the initial value of y component of velocity? Uy was u sine theta. We know initial velocity, we know final velocity, and we know the displacement, and we know the acceleration. So there is an equation which is useful for you. V square is equal to u square plus 2as, velocity displacement relation. Change this one as Vy square, Uy square, Ay square, and S as y. Vy square is 0, Uy square is u square sine square theta. This is minus, Ay is minus g, as if you remember, Ay is minus g. This is minus 2gh. Rearrange them. This will become u square sine square theta over 2g. This is our 8th equation, I think. So we have got all the aspects discussed for this. Now here also we can see that when this will become maximum h for a given value of u is constant. When that will happen? That will happen when sine square theta is equal to 1. When sine square theta is equal to 1, this implies that theta is 90 degree. Theta is 90 degree means this is x and this is y. U makes 90 degree with x axis. Theta is 90 degree. So we will call this one as what kind of projection? We will call this one as a vertical projection. This is a vertical projection. So what will be the maximum value for h? H max will be u square divided by 2g. U square divided by 2g. We have got for vertical projection, the height will be maximum. So that makes the complete aspects of the projectile motion by dividing the problem into one x-axis problem and one y-axis problem. I hope all of you have enjoyed this session and you have understood the projectile in a quick fashion. Thank you very much.